In this video, we're going to look at how to perform in-memory processing using the Tabular Data Calculator tool in RAMP. So let's start the Tabular Data Calculator tool, and you'll see it's here. The first thing that you'll note is that there are two ways to process data in the Tabular Data Calculator. One is sequential processing and the other is in-memory processing. In this video, we're going to look at in-memory processing. Sequential processing was the subject of a previous video. In memory processing, it allows us to address any row or column in the tabular data set relative to the current row. So you don't have the restriction that the sequential data calculator has, that it can only perform calculations on fields within a single row at a time. This allows you to essentially access the entire tabular data set relative to the current row that's being read. So this is a bit more complex than sequential data processing, and it requires all of the tabular data set to be held in memory in order to be able to process in this way. So this is similar to how an Excel spreadsheet allows you to define a function where you can reference any row or column in that particular cell function. This is something that's not traditionally available in GIS products such as QGIS or ArcGIS in their normal field calculator. So we're going to go ahead and look at an example data set, but first I'd like to mention that this type of processing is considered more complex than the sequential data processor. So I would suggest, if you haven't looked at the sequential data processing video, that you have a look at that first, because we're going to skip over some basics in this video to specifically address the more complex in-memory processing functions. Okay, let's go select our input file, and we're going to use the same one that we used last time. And you'll notice that it's listed all the available fields. Now, however, I want to choose that I'm doing in-memory processing. As soon as I do that, it's asked me, hey, do you want to load the sample code? I'm going to click yes, because that gives me a template from which I can build. So this data set is the same as the previous video. It's navigational data from a EM302 series multi-beam echo sounder. It includes the latitude and longitude fields, as well as information such as fixed quality, speed, course over ground, and heading of that particular sensor. In a previous video, we calculated yaw and used the yaw of the sensor as a measure of data quality. In this video, we're going to look at the step change in the heading, so how much the heading changes between subsequent records, and look for sudden changes in the heading as another indicator of potential data quality. Okay, so all the fields are listed here, and the column numbers for those fields within the tabular data set are also listed here. Let's go have a look at our code area now. So again, we're going to expect the function. The function must be public scope, it must be static, it must return a string, and it must be called calculate. Now, unlike the sequential data processor, you can't define the arguments to this function. The arguments must have a long that's called row and an array of strings that's called data. So the row is the current row index position that the tabular data calculator is currently processing. And the array of strings is actually the entire data set. So this allows you to take a row reference and substitute it into the data array, or the multi-dimensional array, and access any of the field values within that data array using a row and a column reference based on the available value fields. So we'll have a look at how to do that in a second. Okay, so let's remove this line. And, oh no, let's not remove that line. Let me first point out that because you're referencing the multi-dimensional data array, which is of type string, you need to perform all the typecasting, conversion, and parsing yourselves. So if you're not sure how to do conversions of type using the parse method of either a double, integer, float, or whatever primitive data type that you are wanting to use, I would suggest you read the Microsoft documentation for those details. But essentially, you have to pass everything from a string into whatever type you would like to work with. So we're going to want to make sure that we're working with a double in this case. So I want to calculate the change in heading. So this will be called delta, I will call it delta th, so delta of the true heading. And we're going to use, so we want to convert the data from the current row at position, and we see that the heading is at position 9, so or column 9. So we want to read the current row, and we want to take away from that, also a double, the row minus 1 at position 9. Yep, so what we've done here is we've said I want current row column 9 minus the previous row column 9 as doubles to return the DTH variable. And then I have to always remember to return as a string. So I'm going to take the result DTH and convert it to a string as my return. Now, exception handling is a little bit different in the for the in-memory processor, because it's good practice to always throw an exception. With the sequential processor, you could return an out-of-bound value, but the best practice for an in-memory processor is to handle the exception by throwing the exception, which means that the current row that is being processed will be ignored from the output data set. Why is that good practice? Well, you can see here, when I'm referencing the row above, my first row is going to be row 0. That means that this row will be referenced as -1, and that's not possible to have in a data array because the bounds are based on index 0. So anything negative doesn't work. This similar is true if I was to be reading, say, 1 ahead or 10 ahead or 10 behind. At some point in time, it's going to exceed the dimensions of the multi-dimensional array. So I need to be sure that if something like this, an out-of-bounds error is thrown because I'm trying to access or reference, say, row -1, that an exception will be thrown and that row will be ignored from processing of the data. Okay, let's run this calculator function and see what it outputs. So I'll need to define the output. We'll just override that. And we will call this delta th, delta true heading. And let's run it and see what happens. Okay, you'll notice in my process information, it says some records could not be parsed correctly. See the input file.err file for a listing of those records that failed. So we knew that some would fail, and this is a result of the exception being thrown in the calculate function code. So let's go and have a look at the output, and also have a look at the error file. Okay, so you can see that it's created the delta th field in the output file, and it's correctly calculated the heading from one step to another. So -0.23 is that heading minus that heading. That, in fact, is correct. So we know that it's worked properly. Let's look at the error file now. And you'll notice that the error file has a timestamp of 11:56:06, and the first timestamp in the output file is 11:56:07. So in fact, this was the first record in the file that couldn't be processed because it was trying to access something one level back, or one row behind. Okay, so this has been a quick introduction to in-memory processing using the Tabular Data Calculator tool. I hope it's been of use to you. Thanks for watching.